So, we're talking about interval and set builder notation, semester, unit 5-1. You guys are going to be able to write the domain and range of a function. First off, raise your hand if you know what domain is. Okay, all right. Never had that happen before. Totally fine. You probably do know it. It's just been a while, right? First day back with math, okay? Well, we'll talk about that when we get further along. This is all right. We're gonna be writing and graphing compound inequalities using interval notation. Okay. Now, everybody recognize this right here?
Yes.
What is that symbol? Less than. It goes a part of the inequalities family, right? You got less than, greater than, equal to, all those, well, less than or equal to, all those different things, right? And if I ask you to graph this inequality, thinking back to Algebra 1, when it's a less than, on a number line, you would put a what? An open circle at 2, and then an arrow going to the left. Okay, it could be a solid arrow, it could be a squiggly one, just something so that way I can recognize that it is going to the left. Okay, and why is it open? Because it's not equal to. Equal to means that it would actually be closed and filled in. Now, to write that in interval notation, you can actually take that graph, take that inequality, and write it in interval notation. Okay, and since I'm representing all the values that are less than 2, what number is the furthest to the left? Not -1. It's negative infinity, because this arrow means what? It goes on forever. It never ends. So, who this is. So what number is the furthest to the left? Negative infinity. So you write that. You write negative infinity. Okay, you write the number that's the furthest to the left on this number line, on this coloring that you've done. Okay? And then what's the number on the right side? 2. Granted, yes, 9 is on the number line, but we're not including those values. It's all the values that are less than 2. So 2 goes here. Okay? We're almost done with writing interval notation. Okay? Interval notation involves 2 numbers, one on the left, one on the right, to represent the furthest left it goes, to the furthest right it goes. Okay? Now, because 2 is an open circle, meaning that it is not included, we need the symbol that represents it not being included, and that would be a parenthesis. Anytime a number is not included on a number line, in this case, or in an inequality, you always do a parenthesis. Anytime that the number is not included. Okay? Now, for infinities, not a bracket, because a bracket means that it would actually be defined. Can we define infinity? No. So infinities, whether they're positive or negative, always has a parenthesis, no matter what. Okay? So when you're writing equality in interval notation, you can either use the graph here. This is more of a visual for you guys to see the furthest left, the furthest right it goes, and then parentheses if it's included. If it's not included, and then you actually use a bracket when it is included. X is less than 2. Less than or equal to 2. Open circle, closed circle on your number line. Close. And I'm going to shade what way? Which way? To the left. So you ask yourself, when you're writing an interval notation, what's the furthest left it goes? And then what's the furthest right it goes? 2. Making sure the comma separates the 2 numbers. What goes around negative infinity? And what goes around the 2? A bracket, because it is defined. Anytime it's an equal to, anytime it's a closed circle, it is defined. And so you put the square bracket. Everybody understand that?
So you ask yourself when you're writing.
Pretty good? Now, real quick, just out of curiosity. Raise your hand if you've never seen this before. Good. Okay. So you scared me earlier when you said domain. When I asked you what domain and range is, y'all said never. Like, okay, yeah. If y'all done this, then y'all definitely have done domain and range. Y'all know that, right? Okay. Guess y'all just rusty. Here we go. X is greater than 2. Open circle or closed circle? Open, shading left or right? Right. To the right. So in this case, what's the furthest left this graph goes? Left. 2. What's the furthest right it goes? Infinity. And the way you write your interval notation is always smallest to largest, just like on a number line. You read from left to right. So 2 always comes before infinity. What's going to be around the 2? A parenthesis or a bracket? It's a parenthesis because it's open, meaning that it is not included. And what goes around infinity? A parenthesis. Awesome. Okay? Can you guys do the next one? You? Open or close? Shading left or right? What's the furthest left that's on this graph? 2. Furthest right? Infinity. What goes around the 2? Very good. And infinity? Always. Those are the easy ones. Okay? Then we'll do this whole thing down. This one you have 2 of them. So you have to do both parts. X is less than 2 or X is greater. So you have to do both parts. X is less than 2 or X is greater than 6. If I do this first part, X is less than 2. What is that around 2? Open circle. And around 6? Open circle. All right. So, open circle around 2. Which way did you shade?
Left.
Left. And then open circle around 6. Which way did you shade?
Right.
Right. Okay. So in situations like this, you're going to have 2 intervals. Okay. Clearly, you got one that's less than 2, one that's greater than 6. Okay. So to represent this part, what's going to go here? All the way to?
2.
What's around at negative infinity?
Parentheses.
And around the 2?
Parentheses.
Still parenthesis. What about this part? You start where?
6.
And go all the way to what?
Infinity.
Infinity. What goes around the 6? And infinity. You're not done though. You have to connect them together. What do you use to connect them? Huh? No, not X equals. Who remembers? When you have multiple intervals. So this might be new. Anytime you have multiple intervals like this, you connect them with the union symbol. From like sets, probability. Does that look familiar? Raise your hand, have you seen this before? A few of you have. Okay, so something new. All right. Yes, anytime you have multiple intervals, you always connect them with the union. So if you had like 3 intervals, then you connect them with 2 unions. Okay? But you do need it because they all go together on one. This one here, it looked the exact same as the one above it, but what's the difference? Closed circles, which means that when you write out the intervals, they should be what around 2 and what around 6? Brackets. So still negative infinity, and then 2 with a bracket, parenthesis around the negative infinity. A bracket around 6, but a parenthesis around infinity. Yes, you can mix and match your brackets and your parentheses. It all depends if it's defined or if it's not defined. And what goes in between them? A union. Anytime you have multiple intervals, there's a union that goes in between them. Okay? All right. Let's keep going. This one here is an example of a compound inequality. This is saying that 2 is less than x, which is less than 6. So if 2 is less than x, but then x is less than 6, how would you graph this on a number line? Open dots at 2 and 6 and a line in between them. Very good. Because it's basically saying it's all the values that are in between 2 and 6. Okay? And that's what you got to write. What's the furthest left? Furthest right? And what goes around the 2? What goes around the 6? There you go. This one's the easier one. What's the difference between the top one and the bottom one? Closed circles, which means it's going to be brackets because it is defined at 2 and it is defined at 6. Please make sure that I can tell your square brackets from your parentheses. Don't make them curved brackets. Those are considered parentheses, okay? Questions on writing in integral notation? Yes? Good stuff. Let's go to something new. Maybe something that have you seen this before? Like notation like that? Alright. This is called set builder notation. This is called set builder notation. Okay, go ahead and open up all your flaps so you can look at this part right here. That is set builder notation. Now there's a difference between interval and set. What's one of the main differences that you see? There's a line instead of a comma. Oh, the line. Anything else? They're curly brackets instead of parentheses or square brackets, right? And on top of that, it got an inequality in it too. Okay? This is another way to represent like a number line of inequality is another way that you can represent your domain and range once we get there. Okay? And it is red. Hopefully you guys can see this. I know the color is a little bit off. The curly brackets represent the set of all x's such that, and then of course your condition. X is less than or x is greater than 0. Okay? This right here is just an example. Okay? Now, depending on what your inequality is, that's what's going to go here. So this part is going to change depending on what you're looking at. Okay? But everything else stays the same. The vertical bar, the x, and then the curly brackets around the ends. Okay? X can change if, like, let's say you're solving a problem and it's g is your variable instead of x, then it changes to a g. Okay? So let's give it a try. All right? When you look at one of your first ones, you have an open circle at -3, and it's pointing to the right. Now, your job in this particular case would try to figure out what is that inequality that represents an open circle at -3 and then pointing to the right. What inequality would that be with an open circle pointing to the right? Oh, there we go. Let's try to call somebody. Okay. What were we going to say? It's going to be x is greater than -3. There's your condition. All you have to add in at this point is your vertical bar, your x, and your curly brackets. And that's it. And it reads the set of x values such that x is greater than -3. And that's it. Okay? Yes, we could write that in interval notation, but we want to be vast in all different ways to represent these different types of notations. How would you represent this? A closed circle at 5 and then point to the left. Let me get a volunteer on this one. Jackson.
X is less than or equal to 5.
X is less than or equal to 5. Very good. If you can get the condition, all you got to do is include the rest. The set of x values such that x is less than or equal to 5. Simple as that. Questions? So far, so good? Those are the easy ones. What about this one? How can I represent that one at the top as an inequality? I have a closed circle at 2, I have an open circle at 5, and then it's all the values that are in between. Eddie.
2 is less than or equal to x, which is less than 5.
Very good. Okay, just like how the other one was on the interval notation setup, you do it the same way. And making sure you include the set of x values such that x is less than or equal to x, which is less than 5. And close it off. Try your best to do your curly brackets. My left curly bracket will always look better than my right, if you haven't noticed. Okay? Now this one. Any volunteers? That's only for interval notation, but I'm glad you said that. The union is only for interval notation. So you need to make yourself a note. Unions are only with interval notation.
Is it only one? Is it one whole thing or is it two?
It's going to be 2, because we have 2 different ones, right?
Yeah.
Let's represent this first one, the one that's over here on the left. How would I represent this part right here?
X is less than or equal to -4.
X is less than or equal to -4. How do I represent the other side?
X is greater than or equal to 4.
And all we do is we just put a comma to separate them. And include the set of x values such that, and that's it. So if you have multiple ones, in interval notation you will use the union. But in set notation, you just write them and separate them with commas. Okay? Unions are only for interval notation, just like infinities are only for interval notation. Okay? Questions? How is this? So far? Not too bad? Okay. Haven't thrown you for a loop yet? All right. Good stuff. Here we go. These should get glued down into your two separate pages. We're going to look at some more examples, and we're going to start making our way into the domain and range categories. Extras in that one. It's all good. Oh no! It's already sorted. Alright, so my mistake is they were already sorted, so you should have one that has a sheet of paper that has graphs on it, and the other one that has problems at the top, okay? So you need 2 pages. So y'all gonna need to put them back together over here. I'm gonna have to go back and pass them back. Pass those back. No. Make sure you have 2 pages. I'm good. 2 pages. Okay, wait, make sure you have 2. Someone is missing 2 different ones.
Wait.
Oh no.
Okay, you have 2 pages, one that has the graphs. So everyone has 2 pages now? Alright, so everyone has one that has these problems on it, yes?
Yes.
And everyone that has the one with graphs, right? Okay. I want you to take, I know it's numbered 5, 6, and 7, and it's going to be number 10, 11, and 12 here. Just ignore that. I want you guys to solve these 3 problems. Does everybody remember how to solve an inequality? Like solving for your variables, like solving an equation? Alright, I'll do the first one with you. When I'm solving this, I pretty much treat the inequality like an equal sign. I need to get my x's on the same side, correct? So what am I going to do? I'm going to subtract the 5x. So that leaves me with 2 is less than 2x minus 8. Huh? Add the 8s. 2 plus 8 is? So I have 10 is less than or equal to 2x, and then divide by 2. Now there was something that was interesting when you did division with inequalities. Who remembers? How many? One person? Two hands. Even though like half the class says it. I know I've heard from both of them today. I've heard from Jonathan. Yes. You flip the sign, yes, so don't forget about that when you divide by a negative. But here we don't flip it because we didn't divide by a negative. So 10 divided by 2 is 5. So I have 5 is less than x. What if I wanted to write it with the x on the left side? I just flip everything. So it really is x is greater than or equal to 5, right? Cool. So if I want to write this in interval notation and set builder notation, I'm already done with set builder, aren't I? I just got to add in all my stuff, right? Okay. So set builder, the set of x values such that x is greater than or equal to 5. And I could have left it the other way, but I want it proper. And then if I'm writing in an interval notation, think about what that looks like on the number line. If you need to draw it out, you can, but I'm going to be looking at the interval notation. You said 5 with a bracket to infinity with a parenthesis. Very good. Okay? So I want you guys to do the next two, interval and set notation, please. There we go. All right. So for this one, what did you have to do at the end? For number 6 on your paper. You had to flip the sign. Did you all flip the sign? And you had to do that at the end, right? You had to flip the sign, right? Okay. So you're going to subtract 9 from both sides. To start with, you have a negative 4w is greater than or equal to negative 3. And then do what? Divide by negative 4. And when you divide by a negative, you have to make sure that you flip the sign. So it should have been w is less than or equal to 3/4. Yes? And there is the condition for your set builder notation. So hopefully you wrote the set of w values such that w is less than or equal to 3/4. Okay? Remember I said that will change depending on what your variable is. How do I represent w is less than or equal to 3/4 in interval notation? Parenthesis negative infinity to 3/4 with a bracket. Questions? Now for this one, this is a compound inequality. And my thing is this, if you're able to solve negative 2 is less than 5b minus 7, and you're able to solve 5b minus 7 is less than or equal to 11, then you're good with this. You just write your answer as a compound inequality because this is a compound equation. Anytime your variable is in between two numbers, that is a compound inequality. Okay? So that means whatever you do to that negative 2, you also have to do to that 11. And you're solving for v. So what are you going to do to get v by itself? Add 7. But I'm not just going to add it to the negative 2. I'm also going to add it to the 11. What's negative 2 plus 7? Less than 5v, less than or equal to 18. Then what am I going to do to get v by itself? Divide by 5. Now I'm not just going to divide the 5 by 5. I'm also going to divide 18 by 5. Okay? Now, again, you guys could have done it separately as two different equations because essentially that's what I'm doing. I'm just doing everything at the same time. Okay? And your answer, if you didn't rewrite it, like flip this part over, you would have your answer as a compound. What's 5 divided by 5? So I have 1 is less than v, which is less than or equal to 18 over 5. Thank you guys for not giving me the decimal. Oh my goodness, I'm so worried. And then you just include the set of v values such that v, or 1 is less than v, which less than or equal to 18 over 5. Angel, can you write it for me?
Yeah. Okay. 1 second.
It's okay.
Okay, parentheses 1. Did you have to wait? Yeah, okay, sorry. Okay.
You good?
Okay, and then 18 over 5 bracket.
Awesome. There you go. Questions? So, you see interval and set notation when you have a graph of inequality, when you actually have an inequality expression, when you're solving an equation, or solving an inequality. Now let's take all that and use it to do domain and range. Okay? Everybody should have this sheet right here. Yes?
Yes.
Okay. We're going to state the domain and range of each function. Now, domain of a graph pertains to the x values. Okay? Domain pertains to the x values. So if you look at that very first graph, right? You look at that very first graph, okay? It's a horizontal line. What's the furthest left that it goes? Negative infinity. What's the furthest right that it goes? Positive infinity. And as you can see, there's the domain right there on your paper. From negative infinity to positive infinity. Okay? That is the interval notation for that. Now, you can write negative infinity to infinity in set notation. But remember, there's no infinities in set notation. What's another way to represent that? Another way that you might know of? No x's or y's involved. Like, when it's every single possible number that exists. All real solutions, right? All real numbers. You use that concept to write this in set notation. It's still the set of x values such that to represent all real numbers, its x is an element of all real numbers. Have you seen that R before? Some of y'all have, some of y'all haven't. Well, if it's your first time, welcome. That represents a number set. It does represent all real numbers. That E is not like a capital with the like sharp edges E, but it represents the element of. That is a different notation, okay? But that's how you would write all real numbers in set notation, okay? Now range represents your Y's, okay? So domain is X, range is Y. That's why it's always domain and range, never range and domain. It doesn't sound right, okay? Range is your Y's. Now this is a horizontal line. What's my Y value? My Y value is 3. Now there's a downside to this. You cannot write 3 in interval notation. Okay? Cannot write 3 in interval notation. But you can write it in set notation. Okay? In set notation, the range, still the set of, this time, since I'm talking about range, I need what variable? Y. Such that Y equals 3. And it's only equals 3 because that's the only Y value that we have. If it went from like 1 to 3, then we would want to write it as a compound inequality. Does everybody understand that? Let's look at this one. It's a linear equation. This arrow indicates that it keeps going down, and this arrow up here indicates it keeps going up. Domain relates to your what values?
X.
What are my x values that are included in my domain for this function? Negative infinity to infinity, or and I heard all real numbers. So it would be the exact same notation as this and this. Everybody understand that? What about the range? Negative infinity to infinity or all real. Okay? So then you would just change it up and you would use Y's for that. Questions? Same concept still applies. How far left does this graph go? How far right does this graph go? Because we read just like a book. We read from left to right. This arrow indicates again that it keeps going down and down, meaning that the x values are going to continue to get towards the negative area. And over here, it's going to keep going up and up and up, and it's going to continue to increase, going over to positive infinity. With the range, it's how low it goes to how high it goes. Make sense? Let's try it out. Let's look at this. We want to give it both an interval and set. Please make sure that on your homework and things like that, you distinguish which one is domain and range. Please. Okay. When I look at this one, this is an example of the absolute value function, absolute value of x. How far left does this graph go? Negative infinity. Anytime there's an arrow, it's assumed that it keeps going on forever. Okay? So I go from negative infinity. That's how far left it goes. How far right does it go? And what do you include around the infinities? Parentheses. How would you write that in set notation? Well, I need the squiggly. What does the squiggly mean? The set of x. That's the bar. The E thing. What does E mean? Element. And the R means? All row. Actually, it's really numbers because we ain't solving nothing, so it's all row numbers. If we were solving some of y'all's solutions, but it's all row numbers. Everyone okay? Good stuff. The range. What's the lowest that this graph goes? 0. What's the highest that it goes? Infinity. If you're able to identify how low a graph goes and how high a graph goes, same thing with domain, how far left it goes, how far right it goes, you have interval notation. Pretty easy. You just got to make sure you include either the parentheses or the brackets correctly. What's going to go around 0? And remember, what does bracket mean? It's defined. And if there's a closed circle at 0, or if it's like a continuation of the graph, like part of the curve at 0, then that means it is defined. There will be a clear open circle if it wasn't. What goes around infinity? Very good. So how do I write everything from 0 included all the way to infinity in a set notation? What's the inequality that represents that? Y is greater than or equal to 0. So then to write the rest of that set, I need the set of y such that y is greater than or equal to 0. Questions? Yes?
So the second one in your domain is always the same as the second one in your range?
No, not always. It just depends on the graph. Try the second one on you. Just the second one. Don't be trying to get all big and bad and go to the other two. All right, Elise, give me the domain. Negative infinity to infinity. What do I need around the infinities? All right. So then give it to me in sets. Leah? Remember that E means element. Good stuff. All right, and what about the range? Zoe? Bracket. -2. Very good. So bracket -2 to infinity parenthesis, and then in set notation. Olivia?
The set of y,
Such that.
such that y is greater than or equal to -2.
Awesome. Yes? Questions? Let's look at the next one. Ooh. Oh, look familiar. Yeah. Quadratics. We never talked about domain and range much. I don't think at all. Quadratics. Okay? All right. Taking a look at this one. If I were to look at its domain, left and to the right, Neil Marie, what would you say my domain is going to be? What would you say my domain is going to be? Did you say it? No. Okay. I really know what you. What will be my domain? How far left, how far right does it go? You see those arrows down there? What's it? Yes, infinities. All right, so if I want to write an interval notation, what would it be?
All right.
And what do you need around the infinities?
Everyone,
Very good. All right.
dust that up.
And then, of course, writing that in set, y'all should be used to this now, right?
Dust that.
Everyone. The set of X such that. So I'm just going to let you guys know that was only 4 people's voices that I heard. Okay?
Get the range.
So next time, I want some unison on that. Okay? Yes, that is the domain. Now I'm looking at the range. I'm looking at the range. How low does it go? How high does it go? Elvin. Hit me with it. How low does it go? It's the lowest that it goes. You see those arrows? Negative infinity. And then with the highest it goes? 4. What do I need around negative infinity? And around 4. Very good. So that's my range. My range is in pink. How do I represent that as an inequality? Because that is the condition part of my set notation. Thank you. Amy, how do I write that? How do I write all the negative infinity to 4 as an inequality? Less than 4. Said less than 4. Okay. Close. It is less than, but it's fine, right? Like what's happening? It's less than, but that bracket means what? It's equal to. Yes. Did you say that? And I just didn't hear you. That's why I repeated what you said. What I heard you say. So you got to correct me. All right. So you said less than 4, but we're talking about range. So what variable do we need? What variable do we need? Say it. I just okay. Range is what variable? Say it. Think about it. You got 2, either X or Y. That's domain. So it gotta be Y. So the set of Y values such that Y is less than or equal to 4. Last one on you. This function for the last one is an example of a square root function. That is the parent function. It does start at the origin, shoots off in the positive direction. Remember, you cannot take the square root of what types of numbers? Negative, because they're imaginary, right? They're not real. That's why it does start at 0 and continue on to what? Infinity. So when you're writing in an interval notation, then Mia, what is it, the domain? 0 to infinity. What do I need around 0?
Okay, so do you do parentheses? Because there's not a...
It's not, but can you take the square root of 0?
Well, I mean...
Yes, you can. So since you can't take the square root of 0, it is going to be included. Because it is defined. It does give you a y. It does give you an output. Okay? So I need a what around 0? And a what around infinity? A parenthesis. What is my range? Anyone? I heard someone whisper it very faintly. Anyone? 0 to infinity. Yes, it's the same for both. Okay? Parentheses around infinity, brackets around 0. Writing in set. How do I write that as an inequality? Because I need that for my condition.
The set of x such that x is greater than or equal to 0.
Very good. And it's going to be the exact same thing for the y's, right?
Yes.
No, they won't always be the same. It really just depends on what type of function that you can get. And let me tell you, you can get some crazy ones. This is just Algebra 2 honors. This ain't at the higher level, but you will get some crazy ones in your time. Okay? All right. How we feeling? Not too bad? Let's combine the last two things. Okay? Let's combine the last two things. Now, the last little bit, we're just going to find the domain of these functions because we ain't ready to tackle the range just yet. Okay? Domain is your input, aka your x's. And if you look at these different types of functions, all of these are interesting. Okay? Everybody knows you cannot divide a number by 0, correct? You get an error message. The reason why is it's undefined. You cannot divide a number by 0. Okay? So, if you have a variable in your denominator, whatever value that's going to make your denominator 0 is not a part of your domain. Okay? So that first thing here says denominators cannot equal 0. So that very first example, f of x equals 1 over x. That's an example of a rational function. Okay? The denominator cannot equal 0 because 0 would make the denominator 0, right? If you plug it in. So that means that is your restriction. It's going to be all real numbers except where x equals 0. Okay? So, to write that in interval notation, that would be from negative infinity all the way to 0. But what's going to go around 0? A parenthesis. And remember, it can't equal 0, otherwise it would be undefined. And that's why we're using a parenthesis. Parenthesis means it's not included. But it goes all the way to 0. It just doesn't include 0. And it's everything from 0 to infinity. Because it's every other number that's out there except 0. Did everybody get that? All right? So, the denominator cannot equal 0. So you have to figure out if the variable's in the denominator, what value is going to make that 0. In the most basic case, which is this, x cannot equal 0. So what would that look like on a number line? Here's 0. Since it can't equal 0, it's going to be an open circle, but it's every other number possible. So it's all of this, and it's all of this. It's everything but 0. Okay? So, negative infinity to 0, but it's not included. It goes so close, but it's not actually ever 0. Does that make sense? and then 0 to infinity. I'm trying to kind of doing it in this general area, like this part represents here, and this part represents this. You feel me?
Yeah.
I hate interval with these. I hate it. The reason why is because if I can figure out what x does not equal, it's so much easier to write it in set. Okay? So all I have to do is, of course, all my goods. And then I just put what x does not equal.
Oh, so
That's it.
you don't have to say
So we don't have to do that.
Mm-mm.
We just do that.
Correct. I mean, because a lot of times I'm just going to tell you, you choose whichever one's easier for you. I mean, your homework, I want you to do both. But like for your test, it's pretty much going to be kind of be up to you. And I'm not going to lie, this is a lot easier to write than this. It's just me, that's my opinion. So let's write it. But that's how you would represent that. Does everybody understand? Okay. Let's look at the example right below it. Okay, you got x over x minus 1 and x plus 3. This is another example of a rational function. But remember, your denominator cannot equal 0. What values are going to make it 0? Well, it's wherever x minus 1 equals 0 and wherever x plus 3 equals 0. What are those values? 1 and negative 3. So the domain is going to be every number except 1 and negative 3, because that's what's going to make the denominator 0, which means it's going to make it undefined. So to write it in set is super simple. X cannot equal 1, x cannot equal negative 3, and then I just need the goods with the comma in between. That's it. It's so simple, because I mean, like, I'm already doing all the work to find out what it is. Then I just gotta include the goods. Just like when you're solving an inequality and writing it, it's a lot easier to write in set because you've already got the condition. Okay? If I wanted to write that in interval, though, what that would look like on a number line, I have negative 3, positive 1. I'm using pink for that. Open circles at both of these, but it's going to be everything except those. How would I represent that in interval notation?
You have to write 3 intervals.
I have to write 3 intervals. This one right here, how would I represent this part? To negative 3 with what around it? Parentheses. Then what about this part in the middle? Negative 3 comma 1 with the what? A union. And then another union. It is. That's why I like set. And to be honest, I would choose set over interval any day. That's just me though. Okay? But that's how you would write it. Okay? That's how you would write it in interval. And that's condition 1. Your denominator cannot equal 0. But in condition 2, when you have radicals, okay, we know that we cannot take the radical of a what? A negative number. So if a radical is involved, whatever's underneath the radical has to be greater than or equal to 0. But if it's a radical that's in the denominator, like this one is, can it equal 0? No. So in this case, it's both rule number 1 and 2 being applied. It has to be a positive number, and on top of that, it can't equal 0 because it's in the denominator. So to figure out the restriction, you set whatever's underneath the radical greater than 0. Because again, you cannot have 0 in the denominator, that's why it's not equal to 0. And you cannot take the square root of a negative number, that's why it's greater than. Make sense? So if I wanted to solve this out, how would I solve that? Subtract the 2. And when I divide by negative 1, what happens? Flip the sign. This becomes a positive 2, and that represents my what? That might be a very vague and general question. That's my condition in set notation. Okay? All I gotta do is just add the goods. That one is a little easier to write though in interval notation. How do you represent that in interval notation?
In parentheses, negative infinity.
To with a parenthesis, because it was less than, right?
Mm-hmm.
Not equal to. Huh? It is. But I'll tell you this. If it's not one of those two rules, if you don't have a variable in your denominator and a radical is not involved, it's all real numbers. Every time, all the time. Promise you. If there is no variable in your denominator and there's no radical involved anywhere in the function, then it's all real numbers. Every time. All the time. Okay? I can show you a few examples of that. This one, it was a quadratic. What was the domain of it? All real numbers. This one, it's absolute value. No fraction, no radical. What was the domain? All real numbers. This was a line. No fractions, no radicals. The domain was what? All real numbers. So unless there is a fraction with a variable in the denominator, or radical, is always all real numbers. Got me? Okay. This will be the last three that we do. I want you to find the domain in interval and set notation. Okay? Use those rules. Use those rules to try to figure out what your domain is for these, okay? Give them a try. All right, let's see. Was this last one a condition, like a rule 1 or 2, denominator radical? What were you dealing with here? A denominator, which means that the denominator could not equal 0 at what value? Or what value did it equal 0? 1. So that means our domain was everything but 1. Set, easiest way I feel. The set of x values such that x does not equal 1. Right? How would you write that as an interval?
Parentheses, negative infinity, comma 1 parentheses, union, parentheses 1, comma infinity, parentheses.
Good stuff. Exactly how you would write it. Okay? So everything but that one value. What about 18? Was it a denominator or radical? It was a denominator one. So there were some values that x could not equal. What were they? So x cannot equal 1 and x could not equal -2. And that was pretty much set notation right there, correct?
Why does it become -2?
Because you have to set the denominator equal to 0. So that's x minus 1 equals 0 and x plus 2 equals 0. So when you solve it, that's how you end up with a +1 and a -2. How many intervals did you have when you wrote an interval notation?
3.
You had 3. You started at negative infinity and then you went to what? -2. Still with the parenthesis and a union now.
-2, 1,
Both with parentheses to.
1, and infinity.
Let's look at that. And the last one. Radical or denominator? You have both. Which means you couldn't have a negative number, nor could you have 0. So that meant you had to take what was in the radical and do what to it? Greater than 0. So x was going to be greater than what value? And then there you go. They're set right there. Including all the goods. This one's not bad to write an interval though. It goes from what to what?
Negative 3.
With what around -3?
Parentheses.
And what around infinity?
Parentheses.
Very good. What if, and this is the last thing, just to make sure everyone's good. What if the function was just this?
Then it just
Negative.
So just be 0, comma, and then
Not 0 to infinity.
negative. Oh,
It'll be -3 to infinity. Because this here is just the radical stipulation. It has to be a positive number. So you would set whatever's underneath the radical greater than or equal to 0 and then solve that. Does everybody understand? There's a difference between being a radical in a denominator, like in the purple, and then just being a radical. Okay?
So it can be 0, just nothing less than 0.
Yes, it could be 0, but nothing less than 0. All right? Questions? Go ahead.